Okay, I just filmed this and then it didn't work out, so I'm refilming it. All right, today we are talking about the fundamental theorem of calculus. Hopefully, from just the title alone, you can see that this is a pretty important theorem because it's fundamental, right? Well, the fundamental theorem of calculus states that given that f of f represents the rate at which the function f is changing, that is, f of x is equal to capital F prime of x, then the integral from a to b of f of x dx represents the total net change in f on the interval a to b. Basically, if a function's continuous on a closed interval and it's an antiderivative, here's what it is. The integral of a to b of f of x dx is equal to the capital F of x from a to b of f of b, which is equal to f of b minus f of a. This is just how we evaluate a definite integral, and this is the fundamental theorem of calculus. So actually, let's do some of these as examples. Here we have the integral from 1 to 3 of x cubed. Well, the integral of 1 to 3 of x cubed dx, I can rewrite, if I evaluate this, this is going to be equal to 1/4 x to the 4th, evaluated from 1 to 3. Well, that's going to be equal to 1/4 times 3 to the 4th minus 1 to the 4th, which is going to be equal to 1/4 times 81 minus 1, which equals 1/4 times 80, which equals 20. That is our answer. Let's do letter B here. The integral from 1 to 2 of x squared minus 3 dx. Well, that's going to be equal to 1/3 x cubed minus 3x, evaluated from 1 to 2. So that's equal to 1/3 times, actually I shouldn't have bracketed it like that. I'm going to do it like this. 1/3 times 2 cubed is 8. 2 cubed is 8 minus 3 times 2 is 6. Minus, I've got 1/3 minus 3. So I've got 8/3 minus 6. 8/3 minus 6 is going to be equal to negative 10/3 minus 1/3 minus 3 is a negative 8/3. So this looks like our answer is a negative 2/3. All right. Let's do a trig one. The integral from 0 to pi of sine of x plus 1 dx. Well, the integral of that is going to be the negative cosine of x plus x, evaluated from 0 to pi. So we're going to have a negative cosine of pi plus pi minus a negative cosine of 0 plus 0. Well, cosine of pi is negative 1, so I have a negative 1 plus pi minus cosine of 0 is 1 minus negative 1 plus 0. So now I have 1 plus pi plus 1. So this is going to be equal to plus pi. All right. Let's do one more here. We have the integral from 1 to 8 of the square root of 2 over x dx. Well, I can rewrite that as radical 2 times the square root from 1 to 8 of x to the negative 1/2 dx. So that's going to equal radical 2 times 2 x to the 1/2, evaluated from 1 to 8. So now I have 2 radical 2 times the square root of 8 minus the square root of 1. So I have 2 radical 2 times 2 radical 2 minus 1, right? So I have 4 times 2 is 8 minus 2 radical 2. Okay? So actually, let's move on here to part 2 of our fundamental theorem of calculus. The fundamental theorem of calculus, part 2. If f of x is the integral from 0 to g of x of f of t dt, then f prime of x is equal to f of g of x times g prime of x. This is the chain rule. That should look familiar to you. This is the chain rule. So let's just do one example here. If f of x is equal to e to the negative x squared and f of 1 is equal to 3, find f of 2 using a calculator. Well, we can see here that the integral from 1 to 2 of e to the negative x squared dx is going to be equal to f of 2 minus f of 1, right? That follows from our fundamental theorem of calculus. So I can actually use my calculator, and it tells me to use my calculator here, to do that. So I'm going to go math, and I believe it's 9 on my calculator, yep, from 1 to 2 of e to the negative x squared dx. And I get 1.35257, so I get 0.13525 is equal to f of 2, which is what we're trying to find, minus f of 1 is 3. Well, now, in order to solve for f of 2, I'm just going to add 3 to both sides. So 3.13525 is equal to f of 2. That's it. It looks really complicated, but it's very simple. So hopefully all of that makes sense to you. This was a short lesson. Like and subscribe, and I will see you in class. Bye!